Okay, this video is about limiting reagents. This is really only for honors, so just fair warning, if you're regular chemistry, I might pause and go to a different video. If you want to watch, that's cool. Fair warning, this is probably going to be a long video because I have a lot to say about this, and they're kind of beefy problems, so stay with me. If you need to put it to 2 times speed, I'm not offended. So in a limiting reagent problem, what you're basically doing is determining who of the 2 givens you have, who essentially stops the reaction from continuing because they run out, okay? That would be who the limiting reagent is, the guy who runs out. Okay, and so a really good hint to use for our test is if you ever have a problem that has 2 givens, like this one right here, you should have a big red flag or a big flashing light in your brain that tells you, whoa, if I'm comparing 2 givens, I have to do this limiting reagent stuff. Because all the other types of problems, they'll just have the one given where you just have to decide how much stuff is needed of the other substance. So really quickly, you need to make sure you have a balanced equation. So I'm just going to give this to you. You need to know how to translate these. So if you don't, go back and look at my other videos and make sure you know how to do this before the test. Okay, what I'm doing right here is in my head, I'm just crossing my charges because these are ionic compounds. This is a double replacement reaction, so I'm going to have to go ahead and switch my metals. I hope I'm doing this right because I'm doing this while doing a video and it could be bad, so sorry. I'm pretty sure this is balanced. Let me just take a second to make sure. Oh, I think I need a 3. Okay, 3 silvers, 3 nitrates, 3 nitrates, 1 aluminum, 3 chlorines, 3 chlorines. Okay, so now I can go ahead and start doing my problem. So part A, it's asking for what mass of silver chloride, so that's my wanted, is produced when we have this much silver nitrate and this much aluminum chloride. So you're just going to do a 4-step Stoic problem, or however much it's asking for. Sometimes it'll ask for the amount of moles. You don't have to do 4 steps when you're getting to moles, okay? But in this case, it's asking us to do 2 problems where we're going from mass to mass. So just do a normal Stoic problem like we've been practicing. So we're going to say, okay, silver nitrate is our given. And I did not write these molar masses down, and I'm regretting this for a second, so I'm just going to Google these. Sorry, I really should have thought ahead. Okay, so silver nitrate, we're just going to start with whatever they gave us for silver nitrate, which was 8.65 grams over 1. Start the diagonal, we're going to put silver nitrate on the bottom, and we're going to get to moles of silver nitrate. Okay, and the molar mass of silver nitrate, what Google says is it's 169.87 grams. Okay, we're going to cross this out, and we're going to move on. Now we're going to do our mole ratio, so we're going to say moles of AgNO3 to, now we're trying to get to silver chloride, so we're going to say moles of AgCl. The number that's in front of silver chloride is 3. The number that's in front of AgNO3 is also 3. And I'm going to put moles of AgCl on the bottom. And then I'm going to put grams of AgCl because that's what I'm ultimately trying to get to. I need to go Google this because I didn't write this before and that was silly of me. This is going to end up being 143.32 grams for every 1 mole. And I know I'm going fast through this part, but by now you guys should know how to just do a Stoic problem. And if you don't, check out my other videos, like and subscribe. Okay, I believe this becomes 7.3-ish grams of AgCl. This is going to be really embarrassing if it's not. I need to double check for myself. Okay, second time's a charm, I think. All right, now I'm going to do my other Stoic. because what I'm trying to see is, well, how much can I actually make? The amount that's less is going to be what I end up actually making, because I can't make more than what I have. So now I'm going to do the aluminum chloride given. So I'm going to go ahead and say, okay, right there, 1.47 grams of AlCl3 over 1. Then I'm going to do my molar mass over here that I have to go Google because I didn't think clearly before I started this video. This is really awkward. Google says this. Who knows if it's right? Okay, I can cross those bad boys out. Now I can move on. I'm going to put moles of AlCl3 on the bottom. And I'm going to put moles of AgCl, who I'm trying to get to. There's a 3 in front of AgCl. There's a 1 in front of that AlCl3. Boom, that crosses out. So now I can get to where I want to go. I'm going to use my molar mass here. Good thing I already Googled this one. It's 143.32 grams for every 1 mole. Cancel out. And when I do this math, using my calculator, unless I'm crazy or my calculator sucks, I believe it's 4.74 grams of AgCl. So how much AgCl are we really going to end up being able to make based on the amount of ingredients we were given here? Well, we can only make up to 4.74 grams, because if we try to make any more than that, we're going to run out of AlCl3. So our limiting reagent right here is AlCl3, and that allows us to make 4.74 grams of AgCl. If we had enough, if we had plenty of AlCl3, then silver nitrate would have ended up letting us make that much. But we don't have enough, which means we can only make 4.74 grams of AgCl. So that's one type of problem you could have for your limiting reagent problems. Another one you could have would be a percent yield problem, okay? And so it'll say, what's the percent yield if the actual yield is 4.05 grams of silver chloride? So the equation we use for percent yield is going to be actual over theoretical. Guys, theoretical really means just the math you did. Okay? Times 100%. This is kind of like, percent yield is kind of like your grade. Like, theoretically, you should get 100% on your chemistry test if you learned everything and you mastered it all. But what did you actually get? Well, you got 80 points out of 100, so your percent yield of what you were able to accomplish was an 80%. So the way we can do this is we can say, okay, actual yield was 4.05 grams of silver chloride. And from the last problem, we determined how much we could make potentially, and that was 4.74 grams of AgCl times 100%. And when I put that into my calculator, it becomes 85.4% yield. So that's a decent percent yield. Okay, so that's another type of problem you can have. I don't think that calculation is that bad. It's just annoying to have to do that other stuff before to be able to get to that theoretical yield. Finally, this is another one that we can do, and this one's a little bit complicated. So our excess reagent is going to be whoever we had leftovers of. And in the previous part, we knew that that was going to be silver nitrate. So what you want to do when you have excess reagent remaining, you're going to want to do whatever your given of that guy was minus how much you used. So, and it's asking for mass, so we have to get it all to grams. So we are given here, we're going to end up using that 8.65 grams that we started with. We're going to use that in this calculation right there. But we need to figure out how much used. So I'm going to do this right here. I hope I have enough room. So you're going to want to go backwards from however much we made. So we said 4.74 grams of AgCl. We have to do a 4-step stoichiometric problem back to grams of silver nitrate. So I'm going to end up using my 4 steps. You might want to like pause and watch what I'm doing because I'm not going to explain this super in depth. But I'm going to divide by molar mass. Then I'm going to use my mole ratio. And then I'm finally going to be able to get myself to grams of my excess reagent. Oh, that is so bad. Okay, I checked myself. I believe this is right. If it's not, comment. Send me a email saying that I'm wrong. I'll take it. Okay, when I plug this all into my calculator, assuming I know how to use a calculator, I believe this ends up being 5.62 grams of AgNO3 used. I'm gonna double check this because I'm doubting myself a teeny bit right now. Oh, jeez. Okay, I got 5.62 again. So that's how much we used. This is how much we started with. They literally told us in our problem that's how much we started with. Now it's asking for how much is left over. So you would say, okay, well, how much did we start with minus how much we used? And when I put that into my lovely calculator, I end up getting 3.03 grams of AgNO3 left over. Okay, and again, pay attention to what unit they're asking for, because sometimes they'll ask how many moles, so you just need to get yourself to moles and not all the way to grams. Hopefully this helps. If you need another video, just let me know, because I kind of just word vomited there, but hopefully that helped.